Fermat was a French mathematician who lived in the early 1600s, and among his theorems, famous types of math that he worked on, there's something that's now known as Fermat's little theorem. And what Fermat's little theorem basically says is that if you take a number like 8 and you raise it, we have some prime number, which I'm just going to say is 13. If you raise 8 to 1 less than the prime, and then you mod it by the prime itself, you're going to get 1. That's what Fermat's little theorem says. A to the p minus 1 will get us 1 if we mod it by p. If you multiply both sides of this equation by a, you get this variation of it, which is something we use a lot. A lot of cryptography is based on this. We'll get into that later. So that version of Fermat's little theorem is going to be useful. So that would say, for instance, if p is 59, which is prime, and I take some number 10 and I raise it to the 59th power, I should get back to 10 if I mod it by 59. But there are other numbers that will get me back to the same number. And the general rule is that you take 1 away from the prime, so p minus 1 equals 58. Oh, well, here's the equation. 10 to the x is equal to 10 mod 59, and this 59 is prime. So to find as many solutions as you want for that equation, all you have to do is take multiples of 58 and add 1 to them. So 1 times 58 plus 1, that gets us our 59, which is one of the answers. 2 times 58 plus 1 is going to get me 117, which is also an answer to that question. And 3 times 58 plus 1 is 175. Now this is all a consequence of this first version of Fermat's little theorem, because if I have a to the p minus 1 is equal to 1 mod p, and I raise both of these things to the power of k, I now have a times something times p minus 1. 1 to the k is still 1. And then if I multiply both sides by a, when you add these two exponents, so you get the plus 1 there. So here's written out in this form. Okay, so for any prime number, this is going to be true as long as the exponent is p minus 1 times some other integer plus 1. Question that they could ask is, 17 to the x is equal to 17 mod 43. I'm just picking a prime. So x is going to be 1 times 42 plus 1, 2 times 42 plus 1, and 3 times 42 plus 1. That one's just 43. This is 42 more than that. That's 85. And this is 42 more than that, 127. And that's how we answer some questions about Fermat's little theorem.